Okay, so sekarang kita tengok addition of inert gas at constant pressure. So the addition of the total pressure of an equilibrium can be changed without changing its volume by adding inert gas. So kiranya kali ni kita akan ubah inert, kita akan tambah inert gas. So the pressure dia boleh berubah lah. Okay, so the addition of inert gas at constant pressure will cause the partial pressure of each gases in the system are lowered. Okay, so kiranya bila kita tambah inert gas, inert gas ni adalah gas di dalam group 18 lah. Helium, argon, xenon, semua tu. Okay, so kalau kita tambah inert gas ni pada constant pressure di dalam sistem tu, what happen adalah partial pressure of each gases in the system are lowered. Okay, partial pressure setiap gas tu akan jadi rendah. Okay, so kenapa? Okay, so kenapa tu kita akan tengok sekejap lagi. And then dia kata thus the equilibrium position will shift toward the direction that can increase the partial pressure. Okay, so since bila kita tambah inert gas at constant pressure, partial pressure of each gases berkurang. So sekarang we need to increase the partial pressure baliklah. So how to increase the partial pressure? Kena shift ke arah yang greater number of mole of gas. So ini macam tadilah yang awal-awal kita discuss about pressure. Okay, so tadi back to this question. Kenapa addition of inert gas at constant pressure akan menyebabkan partial pressure setiap gas dalam sistem tu berkurang? Okay, so for this one, saya akan explain guna slide ni. Okay, so imagine you have this situation here. Ni saya ambil equation sama je macam tadi. Okay, so sekarang kita nak add inert gas at constant pressure. Okay, so initially, okay, sebelum inert gas tu masuk, kita ada 3 jenis gas dalam ni. Okay, partial pressure of PCl3, PCl2 and PCl5. And this total partial pressure ni, let's say lah, saya letak 8 atm. Okay, and kenapa 8 atm? Okay, mungkin lah, let's say PCl3 the partial pressure is 2 atm, partial pressure of Cl2 is 2 atm, while partial pressure of PCl5, let's say 4 atm. So total up, the total partial pressure is 8 atm. Okay, so this is pressure before addition of inert gas. Okay, so now saya tambah inert gas, in this case adalah helium. So saya add helium masuk dalam sistem tu. Okay, so walaupun saya tambah helium dalam sistem tu, tapi total pressure dia tetap sama. So kenapa total pressure tetap sama? Sebab kan kita cakap tadi kita add inert gas at constant pressure. Constant pressure tu refer kepada total pressure. So total pressure dia yang sama. Okay, so bila total pressure dia sama 8 atm, so logically dalam ni partial pressure ni kena berkurang lah kan. Okay, so that baru boleh dapat 8 atm sebab sekarang we need to take into account the partial pressure of helium. Okay, so let's say partial pressure of helium is 2 atm. Okay, so partial pressure of PCl3 dia dah tak boleh 2 atm lah. So maybe dia 1.5 atm. Cl2 2 atm tadi mungkin 1.5 atm juga, and then partial pressure for PCl5 maybe 3 atm. So that when we add them up, okay, 3 tambah 5 tambah lagi 3, so jadi 8 atm. Okay, so hopefully kamu boleh nampak. So bila kita tambah inert gas, okay, so partial pressure setiap gas ni akan berkurang. Okay, so kenapa dia berkurang? So that dia punya total pressure dia still constant. Okay, so itulah yang berlaku apabila kita tambah inert gas lah. So conclusionnya, when we add inert gas at constant pressure, dia punya partial pressure of each gases akan berkurang. Okay, so now kita dah faham partial pressure tu berkurang. So next, we need to think how to increase the partial pressure. Okay, so to increase the partial pressure, the system will shift to direction that have greater number of mole of gas. Okay, so keep that in mind and let us try example 1. Okay, so example 1, addition of inert gas at constant pressure. Okay, so PCl3 plus Cl2 PCl5, equation sama. So addition of inert gas at constant pressure will cause the partial pressure to decrease. And then the system is not at equilibrium. the equilibrium position will shift toward the direction that have a greater number of mole. Ini saya tips saya bagi tadi kan. Okay, kalau the partial pressure decrease, okay, that means kita kena increasekan balik partial pressure. Cara nak increase partial pressure, kena shift ke arah greater number of mole of gas. Okay, so nak determine number of mole of gas, tengok balik kepada equation lah. Sini 1. So total reactor ni ada 2 mole. Untuk produk pula hanya ada 1 mole. So kita kena shift ke arah greater number of mole. That means we need to shift to the left. Okay. So when we shift to the left, the concentration of PCl3 and Cl2 increase. And the concentration of PCS5 since berkurang menghasilkan PCl3, so decrease lah. Okay. So itu je lah. For addition of inert gas at constant pressure. Kiranya key point dekat sini, kamu kena faham apabila kita tambah inert gas at constant pressure, partial pressure dia tu akan berkurang. Partial pressure mean pressure of each gas ni akan berkurang, tapi total dia akan masih sama. So macam mana nak increase balik partial pressure tu? Dengan cara shift ke arah number of mole yang lebih besar. Okay. So next, kita tengok lagi another example. Saya bagi example lain pula lah. Okay, menggunakan equation lain. So addition of inert gas at constant pressure, this causes the partial pressure to decrease. Sama juga. Walaupun equation lain, the effect is still the same. That means when we add when we add inert gas at constant pressure, partial pressure of each gas tu akan berkurang. Okay, so the system is not at equilibrium, and the equilibrium position will shift toward the direction that have greater number of mole of gas. Okay, ini macam nota je lah. Okay, so greater number of mole of gas, but in this case number of mole of gas dia lain dah daripada yang tadi sebab ini equation lain kan. So kita check satu-satu. So on the left hand side right now, which is for the reactant, since the stoichiometry adalah 2, that means sebelah kiri ada 2 mole. Okay, for product pula, for product ada 2 mole plus 1 depan ni. So 2 plus 1 equal to 3 mole. Okay, so sebelah product 3 mole, sebelah reactant 2 mole. So kita nak increasekan the pressure, kita kena shift ke arah greater number of mole. That means kita kena shift ke arah 3 mole lah. So that means we need to shift to the right. Okay, so the answer here, shift to the right. So when we shift to the right, that means the concentration of H2 and O2 here will increase while the concentration of H2O will decrease. Okay, so seterusnya kita tengok example 3. Addition of inert gas at constant pressure, and this is the equation. So the equilibrium position is apa? Okay, so kat sini dia ada kelainan sikit. Sebab kalau kita check over here ada 1 mole, ini 1 mole. So 1 plus 1 total reactant ni ada 2 mole, and sebelah sini pun produk pun 2 mole. Okay, so since kiri dan kanan 2 mole, so kalau kamu jumpa soalan yang macam ni, okay, walaupun addition of inert gas at constant pressure, nak shift arah mana? Kiri kanan. So tak perlu nak shift sebab dia punya mole dia sama. So the equilibrium position is not affected lah, tak terganggu. Okay, so the number of mole of reactant and product are the same. Okay, alright. Okay, so settle untuk addition of inert gas at constant pressure. Okay, so next kita tengok addition of inert gas at constant volume. Okay, so tolong betulkan saya tersalah tulis ini, bukan at constant temperature tapi constant volume. Okay, so next kita tengok description dulu. Addition of inert gas at constant volume will cause the total number of gases molecule to increase. So kiranya kalau kita tambah inert gas at constant volume, total number of gases molecule tu akan meningkat. Yalah, sebab tadi ada gas A. Contohlah ada gas A, gas B, gas C je. Sekarang ada inert gas. So ada A, B, C dan inert gas. Okay, so obviously total number of mole of gases molecule akan meningkat. So bila ada gas baru masuk, logically dia punya total pressure of system akan meningkat lah. Sebab sekarang kita tak constantkan pressure tu, tapi kita constantkan volume, bekas tu sahaja. Okay, however, the partial pressure of each gases in the system remain unchanged. Total pressure tu meningkat, tapi partial pressure setiap gases di dalam sistem tu masih sama. Okay, so dia kata therefore addition of inert gas at constant volume has no effect on the equilibrium position. So kiranya bila partial pressure of each gases tu sama, so kita tak ada perubahan apa-apalah terhadap equilibrium position dia. So dia actually addition of inert gas at constant volume will not affect the equilibrium. Okay, so kita nak faham lagi explanation this one. So saya pergi page yang seterusnya. Okay, so tadi kita belajar addition of inert gas at constant pressure. So sekarang addition of inert gas at constant volume. Okay, so imagine dalam satu bekas ni, dalam satu container ni kamu ada gas A, gas B, gas C. Okay, so partial pressure of gas A, B, C total equal to 5 atm. And then partial pressure of A, let's say lah 1 atm, partial pressure of B 2 atm, partial pressure of C 2 atm. So total up equal to 5 atm. Okay, this one before addition of inert gas. Tapi sekarang kita tambah inert gas tapi at constant volume. That means the size of the container is the same. Tapi helium masuk dalam ni. Okay, so bila helium masuk dalam ni, so obviously sekarang dalam container kita ada partial pressure helium, ada A, gas B and gas C. Okay, so total partial pressure ni sekarang dia dah bukan 5 atm sebab dia ada gas yang baru iaitu helium. Dia dah jadi 7 atm. Contohlah saya letak. Okay, so kenapa 7 atm? So sebenarnya another 2 atm yang baru bertambah tadi datang daripada helium. And as you can see, the partial pressure of gas A, gas B and gas C masih sama. 1 atm, 1 atm, 2 atm, 2 atm and this one also 2 atm. Okay, so since kita tambah inert gas at constant volume, dia punya partial pressure of each gases ni tidak berubah. So kita anggap equilibrium position tu pun tidak affected, tidak terganggu lah. Okay, so hopefully boleh faham. Ni situation ni lain daripada yang tadi. Okay, and then so kalau kita nak faham, kita kata tadi, partial bila addition inert gas at constant volume, dia punya total pressure meningkat, partial pressure of each gas tu masih sama. So disebabkan partial pressure tu sama, tak ada perubahan terhadap equilibrium. Okay, so the next yang sebelah ni nak explain apa? Nak explain kenapa partial pressure of each gas tu tak meningkat. Okay, so sebabnya kalau ikut formula Dalton's law, PA equals to NA RT over V, ini adalah ideal gas equation. Susunkan, kan saya cakap kalau nak cari partial pressure of A, number of mole pun mesti number of mole of A. Darab dengan RT over V. Okay, so in this case, dia kata adding inert gas at constant volume does not change any of the quantities on the right side of the above equation. So, bila kita tambah inert gas at constant volume, value yang sebelah kanan ni, which is number of mole, RT dan V ni tidak berubah, dia kata. That's why partial pressure of A ni tak berubah. Okay, so kita check. Number of mole of A berubah ke? Taklah, sebab bukan kita tambah gas A, kita tambah helium gas. Okay, which is lain daripada A. Okay, and then R is a constant, gas constant, so memang sentiasa sama. T pula adalah temperature. Eksperimen ni memang di carry out at the same temperature. Okay, mana kita carry out? Kita akan selaraskan suhu lah. Okay, and then for volume pula, volume kan kita cakap tadi at constant volume. So, N tak berubah, R tak berubah, T tak berubah, V tak berubah. That means the partial pressure of A pun takkan berubah bila kamu tambah inert gas. Okay, so PA ataupun partial pressure of A remain constant. Therefore, the addition of inert gas at constant volume has no effect on the equilibrium position. Okay, so kamu kena ingatlah yang ni. Kalau soalan bagi addition of inert gas at constant volume, senang sangat sebab tak perlu nak shift kiri, tak perlu nak shift kanan sebab dia memang has no effect on equilibrium position. Okay, settle.